Here's an animation from our textbook publisher describing an ordinary air mass thunderstorm. It starts out in the cumulus stage with initial vertical lifting. In this case, thermal convection, late afternoon, when most thunderstorms do happen. The ground got hot and the hot air started rising. The initial lifting might also be caused by two fronts colliding or two air masses colliding, or an air mass coming in and hitting a mountain range. A variety of things could cause that initial lifting. But here, let me go ahead and play this. And we can see the development, the rising air, and the condensation occurring. And when it's in the mature stage, there's heavy rainfall and vigorous vertical lifting. But then the dissipating stage, the cold downdrafts caused by the evaporation of the raindrops wipe out the uprising air and essentially kill the updrafts. And so an ordinary air mass thunderstorm usually lasts maybe 20 minutes, a half hour. Another thing that shuts off the thunderstorm in this case is that the cloud itself will block sunlight from getting down to the ground, and so the energy source that caused the initial lifting disappears. In a severe thunderstorm, this is a severe thunderstorm, you've got fairly high wind shear and a tilted downdraft, updraft. And so in this case, the downdraft doesn't wipe out the updraft. It can actually cause a new cell to develop. And if this moves into new regions, the sunlight will be available to warm this ground here, and this thing may persist for several hours. So the severe thunderstorm, the big difference is that this slanting downdraft and updraft don't work to wipe each other out, but actually work to reinforce each other and develop new cells.